All right, so this is the second part of question 5. Oh my, question 5 has question 5, 2 parts, and each part, eh? Okay, so this is the second part. It says using A, MOSFET, B, any other component. So question 5, we have done the first part. This is the second part of question 5, okay, and has 2 parts. The first part of question 5, second part, is using MOSFET. Oh, Bob, those you said that wrote this exam, it's all good, it's all good. So using A, MOSFET, then use B, using any other component of your choice. What are we to do? We are to discuss the design, okay, the simulation and performance comparison of what. Let me just highlight what we're actually doing. Comparison of audio receiver and what, sorry, audio transmitter and receiver. That's what we are doing. Comparison. We'll consider MOSFET, then any other component. How MOSFET is used as a transmitter and as a receiver. That's for MOSFET. How other components are used as transmitter and receiver. So we'll now compare the two components, how they do their transmission and receival of signal. Okay, so first of all, when we say transmit or an audio transmitter, what we are talking about is a circuit. Bear that in mind. We are talking about a what? A circuit. And circuit does what? Converts audio signal into signals that can be transmitted over distance. Convert audio signal, okay, into signals that can be transmitted over a distance. That is for transmitter. Okay, transmitter. All right. Then for receiver, it receives transmitted signal and converts them back into audio. So you have this transmitter, then you have this receiver. So the audio signal is transmitted by the transmitter. Audio signal gets in to the transmitter and it is sent over a long distance to the receiver. The receiver converts this thing back to what? Audio. Are we together? So transmitter, receiver. Good. Now, what transmitter and receiver design using MOSFET, that's A. Transmitter and receiver design using another component, that's B. So we'll now compare the two of them. Now, design using MOSFET. So MOSFET can be used for amplification, switching, and modulation stage. Now look at the basic transmission block. There are 2 blocks here. Of course, 2 blocks. Block of transmission and block of receiver. Transmitter and receiver. So for the transmitter block, microphone, which is the beginning, like you speak into the mic, hallelujah. So you microphone, and then what? Audio from microphone to where? The audio amplifier. From the audio amplifier to the modulator, okay, which of course puts our signal into a carrier signal. We've talked about that in other courses, okay. So let's not talk about that one here, other videos. So but just know that this has to do with what? Wireless communication, okay. So that is EEE 561. Yeah, that's it. So microphone to audio amplifier to modulator, which will now modulate that our input signal, and then what? To radio frequency what? Amplifier, and then to what? The antenna, of course, from antennas then to the receiver. Now this is the receiving block now. So the basic receiving block or receiver blocks, the antenna, from this antenna sends to what? Another antenna. And what happens was radio frequency amplifier. Can you look at this thing, guys? First, what am I saying? First, second, third, fourth, fifth. This fifth now is the what? First. This fourth now is the second. It's just like we turn You see this line, you just reverse it. Okay, that's what you have here. Are you seeing it? So what's going to happen now is what? So what do we have here? What do we have here? So antenna comes first to receive that sent signal, and then radio amplifier comes in to amplify that received signal, and demodulator, that's the opposite of that modulation, okay, to take out our signal, our received signal, from separate the received signal from the carrier signal. And then we now have what? We have to amplify that our signal, the demodulated signal has to be what? Amplified, and then comes out with the speaker. Somebody shout hallelujah. Next is what? The importance of MOSFET, okay? So why some persons prefer MOSFET, okay, for this transmission and receiver stuff. So MOSFET are preferred because they what? They have high input impedance, and what? Low power consumption. I think we talked about this in the last video. High input impedance, that means they resist the inflow of, resist the flow of current. Impedance, resistance, same idea. So or similar idea, same idea. So they have high input impedance, and they what? Consume low power, like low power consumption, and they switch really what? Fast, and they are good thermal what? They have what? Good thermal stability. They don't get hot like that, just become so hot and things like that. So all right, so that's what some of their properties. Okay, so performance of MOSFET design, the advantage and the disadvantage. When we consider their performance of a MOSFET design for receiver and transmitter, what's the advantage is that it has what? Low noise and what? High efficiency. In fact, you can even think of high efficiency because we see from here low power consumption, fast switching, good thermal stability. So of course, high efficiency. Okay, we've already mentioned high input impedance as one of the reasons why people prefer it. So of course, it's an advantage. High input impedance, and we already mentioned fast switching. So of course, we can talk about what? Fast response. So these are the advantage, almost like repeating what we have here. For the disadvantage, it is sensitive to static electricity. It is sensitive to it. So that means it can lead to maybe possible misinterpretation of signal, okay, or distortion of signal, because it is sensitive to what? Static electricity, which is not even part of our input signal or received signal. As in, we don't expect that to be part of our signal, our information. Then since this guy is MOSFET is sensitive to static electricity, it might include that static electricity to our information, which will cause what? Distortion. And in a way, and it's also expensive compared to other components used for this amplification. And then gate damage is possible because this guy uses source, gate, and drain, not like BJT that make use of 3 pins called the base emitter collector. For MOSFET, they use 3 pins called gate, source, and drain, and the gate can be damaged, possible damage. So for using other components, for this same sending and receiving, we are using what? BJT. I think I mentioned BJT just now, bipolar junction transistor. So for this BJT, using it as design, it is also used for what? Amplification, modulation, and signal what? Processing. Look at the transmitter block. It is similar to the transmitter block of this one, okay, just that in place of this, you have what? BJT amplifier here in place of what? ROF, where transmitter, in place of just audio amplifier. Okay, so you have what? BJT amplifier, then of course to oscillator, and then to antenna, and then the opposite, antenna, tuner in place of oscillator, and then BJT amplifier, microphone, speaker this time. Okay, then for the performance of BJT design, it's just the advantage and disadvantage. Okay, so it is simple and low cost, then high gain. Okay, it is cheaper than a MOSFET, so of course low cost. But for the disadvantage, lower input impedance. It doesn't have high input impedance like the MOSFET. This one is, the input impedance for this guy is low, so in rush of, like, you have high currents coming in and things like that. Okay, now then high power consumption. It consume, of course, when it has low input impedance, it will consume more current, and of course high power what consumption. And then more thermal issues. That is thermal issues, that is heat, things with heat. Okay, things like that. So this table just gives us a summarized comparison with the two of them. So look at the parameters, the components. MOSFET is for MOSFET, the first guy we talked about, and BJT, the second guy we talked about. So the parameters for input impedance, we said that MOSFET is high. Okay, so less current coming in, consume less current, or draws less current because it resists the flow of current, electrons. Then for BJT, it has low impedance, meaning it draws more current. So because it draws more current, of course the power consumption for BJT will be high. This guy that draws less current because of the high resistance or high impedance, it will draw what? Less power. So the power consumption for it to be what? Low. And this guy has an advantage. MOSFET has an advantage of what? Switching speed. MOSFET is fast. Okay, and then for BJT is what? Moderate. Now note that since this guy draws, the power consumption is low, of course for thermal stability, which is heat and things that have to do with temperature, it is better. Okay, power consumption is low now, so in terms of heat it's better. But for this guy, oh, it's lower. Okay, it gets hot. It has issues with temperature and heat, things like that. Then for this guy, for cost, this guy is more expensive, and this guy BJT is more expensive. Okay, sorry, BJT is not expensive compared to MOSFET. MOSFET is more expensive. Then for gain, MOSFET has moderate gain, BJT has what? Higher gain. Then for noise performance, well, this MOSFET is better. Okay, then BJT is just moderate. Now for the simulation process, of course, the transmitter, for the transmitter and receiver side, the two sides, transmitter, we apply inputs, we apply audio inputs, observe the modulation, and then monitor the transmitted waveform. This is for the transmitter side of the simulation. Apply audio inputs, then observe that modulation, what's going on, then you monitor the transmitted waveform. For the receiver side, you apply received radio frequency signal, and then you observe the demodulated audio, and then you analyze the output and quality. Okay, so that's it for this video. Thanks for watching. Like, share, subscribe, and I'll see you in the next one. Bye for now.